Back in August 2020, I constructed this deck at the bottom of my garden for a hot tub. I built the deck with 4 pillars in the hope that one day I'd get round to putting some sort of pergola or roof structure on top. But as so often happens, this remained a pipe dream with all the other jobs piling up until this Christmas, when my son suggested, or rather demanded, we finally complete the pergola. So today's video is all about how, with his help and a few rough ideas and some very basic materials, we ended up constructing this. Now, I sourced all the wood for the deck from my local agricultural supply stroke DIY yard down the road. And a link to my decking video is coming up on screen now, and will also be in the description below this video. For the roof or pergola, I always had in mind a sort of contemporary box-like structure, rather than the more traditional designs of pergola that you tend to see. The pillars were constructed from 4x4 inch sawn tanalised timber, with the same sawn material being used for the 6x2 inch deck substructure. It was pretty basic stuff, often wet, always kept outside in the yard, and something I typically had to sort through to find the least warped or bent sections. It certainly wasn't the superior kiln-dried C16 or C24 grade stuff that's most often used in the building industry and which you tend to see at your building yards or timber merchants. And it's not the cheapest either, but I love this place and its metal shop, where they've made me these very cool curved benches for the hot tub, which I'll be doing a video on soon. Now, I wanted to make the roof structure from similar wood to match the pillars, but the problem was I couldn't find 4x4 inch timbers that were wide enough for 3.6 meters that I needed to span the pillars. Also, by this time, 2 of the pillars, including this one, were quite badly twisted as well as a little bit cracked. And this was something I was going to have to factor into the design, because you often see pergolas bolted to the side of the pillars. So after mulling this over for several months from time to time, by the time my son demanded we make this, I'd come up with a bit of a plan to screw together 2 of the longer 3.6 meter 4x2 inch joists to make my own 4x4 inch framework for the roof. But I couldn't be sure it wouldn't bow over time, so I decided to strengthen it with some internal metalwork. Again, available from the same agricultural supply yard, in 50mm by 3.5mm thick bands. Was this necessary? Probably not, but I'm not very good at calculating loads and tolerances, so I always like to overcompensate in this sort of situation. And I also thought that by strengthening these joists, I'd provide a useful talking point for you guys, and perhaps you might like to let me know in the comment section below if you've made a roof like this, whether you've had any problems with it bowing. Anyway, before we go any further, let's have a quick look at today's toolkit. 14 3.6 meter lengths of 4x2 inch timber. I only ordered 12 and had to buy 2 more of graded timber from another timber yard, my local place being shut due to COVID at this time. 1 length of 4x3 timber, Sudal Pro 45p ultra fast setting polyurethane glue, adjust tight screws 4.5 by 75mm, 6.7mm by 200mm index timber screws from Timco, although loads of manufacturers supply them, 7 by 100mm forge fast timber screws, again lots of manufacturers supply these, Evolution sliding bevel saw, DIYte DW624 half-inch shank router, and I thought I'd see which worked better out of these 2 50mm router cutters, impact driver, drill driver, and 4x30mm outdoor screws, 10mm polycarbonate sheeting and accessories that I bought from sheetplastics.co.uk, Dremel for trimming the aluminium roof sections, not essential but a great bit of kit, mini guttering from guttersupplies.co.uk, and hex washer roof screws. I actually bought those steel bands several months ago, and the first job was to treat the light film of rust that had formed on them, which I did with the brilliant Nutrirust, a link to my recent video on which is coming up on screen now. What the Nutrirust does is neutralises the rust, as the name suggests, and encapsulates the metal in a hard water insoluble film. I didn't bother with a top coat, as the steel bands are going to be encased in wood under a polycarbonate roof. Now, the next step was to insert those bands in the 4x2 inch joists. I could have just sandwiched them in between, but that would have left them a bit exposed to moisture. So instead I decided to route a shallow channel in between. I bought this 50mm router cutter bit from Amazon for $20.99. Unfortunately, it's currently unavailable. And also got sent a Trend tenon cutter free of charge to see which would work best. To cut the channel, I was using my DIYte half-inch shank router, which I've owned for years, with a fence attached to maintain a straight cut. Ideally you'd use a router table with these cutters, and in fact the trend is recommended only for use with a router table. But like a lot of you lot, I don't have a router table. And actually the router performed brilliantly in cutting what is after all quite a shallow groove of about 4mm in depth down the length of each timber. The trend cutter, as you'd imagine, was superior in cutting performance. In short, it was easier to draw it down the timber, but the cut wasn't quite wide enough, and the Isuku Amazon cut was perfect for slotting in that metal band. And at £20 compared to 80, I think I know which one you'll be picking for a job like this. Now, to glue those joists together, I had two options: exterior PVA, which I'd normally use, or this ultra fast setting Sudal polyurethane glue I bought some time ago for an outdoor furniture project that I'll be filming in the spring. So on this project today, I thought I'd try out the Sudal. I haven't used it before, and I had a suspicion that the expansion properties of the glue would be ideally suited for this quite rough sawn timber. And I'm really pleased I used it. Just look at the way it expands. Now, I had these 4.5 by 75mm Joists screws in my store. I've never found a job suitable for them until now, but they were perfect for this, with their tiny 7mm diameter head almost disappearing into the joists. I haven't used Robertson head screws before and found they did slip a bit on the screw, which is a bit disappointing, but I hadn't realised the box came supplied with a bit, which, although obviously the same size, is a much better fit than mine, so it pays to check if the manufacturer has supplied its own screw bit with the pack of screws. Any expanding glue between the beams can be easily scraped away with a decorator's knife. I wanted to slope this roof down to a gutter system at the rear of the deck, and the polycarbonate roof sheeting requires a minimum angle or slope of 5 degrees. So I needed to make an angled cut on each pillar, all of which had been cut at 90 degrees and set at an identical height off the deck when it was constructed. So we marked a 5-degree angle on the pillars with a protractor and trimmed them with a combination of hand saws, my 18-volt sander, and my son was particularly keen to try out this 10.8-volt mini chainsaw pruner I recently got sent by Steel. I'll be doing a video on this at some point, but I'm just road testing it for now. I spent a long time thinking about how to secure the roof beams to the pillars. Butt joints were the obvious choice, but I also liked the idea of a mitre joint because then both beams would in part be sat on and therefore could be secured to the pillar. I wasn't sure if I'd need additional brackets below, but decided to fix the beams down with maximum strength by using a combination of the polyurethane glue and 6.7 by 200mm long Timco timber screws bought from Amazon. I wasn't worried about cutting the steel band inside each beam because the Evolution saw, whilst not the best in terms of accuracy, does at least have a universal blade that can cut steel and wood. When I constructed the deck, I stupidly didn't check the diagonals, so I've ended up with a slightly skewed square. So we cut each end of the first beam to 45 degrees, glued and screwed it down, and then marked the next beam off the one it was joining to in order to ensure the miters butted up as closely as possible. So each pillar has 2 screws, one in each beam, securing them vertically down into the pillar. We then glued and screwed the beams together with 2 of the 7 by 100mm forged fast timber screws bought from Amazon. The beauty of the polyurethane glue is that it expands into any gaps left between the mitre, which again can be trimmed down easily, in this case with my Irwin floorboard saw and penknife. We're always going to make mistakes doing DIY, like my son here over tightening this screw, but the expansion properties of this glue solve a multitude of problems. With the main roof beams in place, it was obvious to me that there was no need for any strengthening with brackets below. For the internal structure, I played around with a few ideas, using Microsoft Word as a very lo-fi way of visualising the different options, and in the end settled on this, as I realised I was going to need to join the polycarbonate roof sheets in the middle, and this design would give the roof sheets fairly uniform support, with the diagonal beams further strengthening the structure and minimising lateral flex. By laying each cross strut on the main beam, I could mark the angle with a pencil and cut it on my mitre saw. We then drilled pilot holes with the struts in place and secured them with 7 by 100mm timber screws and polyurethane glue. And in case you're wondering, the timber screws secured at an angle into the main beams were in no danger of hitting that central steel band. For the central beam, I decided a 4 by 3 inch beam rather than the 2 steel reinforced 4 by 2s would be fine. And again it was glued and screwed into place, this time with the longer 200mm deck screws. I really liked the design at this point, but just felt it needed 2 more cross braces to support the polycarbonate sheeting. The first was screwed through the central beam and the second secured in place on both sides of the beam using those Adjust Tight screws. The aim of this project was very much to make the deck weatherproof so that we could enjoy the hot tub in all weathers. So the penultimate stage was to add roofing sheets to the pergola, and after a bit of research online I settled on sheetplastics.co.uk, who I hasten to add haven't paid me anything for the mention in this video, nor have any of the other suppliers that I've mentioned. I had 2 sheets of 10mm clear twin wool cut to size 330mm long, with each sheet 1850mm wide. I also needed a central glazing bar to join the 2 sections, aluminium F sections for the front and sides, and sheet closures for the rear of the roof where it slopes down to the guttering. The twin wool is UV protected on one side and comes with foil tape at the top and bottom, with the bottom tape perforated to allow ventilation to the internal compartments. I mentioned that my deck was slightly skewed, and so we had to trim each side of the polycarbonate sheeting to get it to fit flush with the edge of the pergola. And we trimmed the sheets down with my Urbau plunge saw and tracks that I bought for the wardrobe project last year. Now this is a bit problematic because plastic splinters can get into the flutes while you're trimming it. The other major issue with trimming the sheeting down yourself is that you lose the rounded factory edge, which makes it so much easier to fit the F sections onto the side of the sheets. Without that rounded edge, I had to apply additional foil tape to keep dust and other debris out of the compartments, and it was incredibly difficult to slide the F sections onto the polycarbonate sheet. The central glazing bar ensures a weather-tight seal for the 2 polycarbonate sheets, but I made this mistake of using these panhead exterior screws to screw down the glazing bar, which meant that it didn't click down properly, as you can see here in this mock-up. So when screwing yours down, make sure you use very low profile screw heads, a bit like I did here when I ended up having to take the glazing bar weather seal up and change the screws for these Loctite screws. With the sheets finally cut down to size, the F sections were then mitered in the corners with my miter saw and drilled and screwed in place with the exterior screws from Tite Fix. I left a 5cm overhang at the rear of the roof for any water from the roof to drain into the guttering. The F section closes off 3 sides of the roof and has the effect of securing down the polycarbonate sheeting, with the last section having a plastic sheet closure which allows air to circulate around the perforated foil. There's not much information online about how to install these things, so I took a common sense approach, and I've probably made a few mistakes. But to my mind, the important thing is to keep the F sections clear of the rubber seals on the glazing bar, so as not to compromise the waterproofing provided by that seal. So I used my Dremel to trim down the F sections so they could butt up but not interfere with the glazing bar, and this metal file to tidy up the cut edges. And this enabled me to extend the F sections behind the glazing bar end cap for a really neat finish. And speaking of waterproofing, I bought this multi-purpose sealant on the recommendations of Sheet Plastics, but I've not actually used it because I failed to see where it's necessary.
Although I should probably put a bead where the polycarbonate sheet slides into the F section.
The final step was to screw down the polycarbonate sheeting to stop it flapping on the rafters in the wind. You have a few options here, but I used these hex washer roof screws left over from an earlier greenhouse roofing project.
Positioned along the diagonal rafters and bottom beam.
Now, I was keen to install some guttering, and I'm glad I did, as this is what happens when it rains during the install of the roof sheets. I found this mini guttering on guttersupplies.co.uk, perfect for garden sheds and projects like this, where you don't want to use full-size guttering.
With a pencil line down the length of the back beam marking a gradual fall of about 2 cm per 5 metres, it was simply a question of screwing each gutter component, fascia brackets and stop end outlet into position, and then clicking the gutter into place.
And as you can see here, it's almost completely hidden behind the pergola structure and diverts all the rainwater off the roof down into the flower bed behind the decking. If I had one criticism, I'd say the guttering is a little too flexible and has warped at one end. So in spite of all my efforts and attaching the gutter at a precise angle to the roof beam, it just doesn't look completely straight. And in the process of unclicking the center joining piece to try and adjust it, I ended up snapping one of the clips
on the union bracket. I've temporarily bodged it with CT1 and gutter sealant, but it will have to be replaced, which is annoying.
So finally, you're probably wondering what all this cost. So I've pulled together the figures, and I've got to say I was a bit shocked to find out we've come up with a grand total
of £750.
Over half of this was the polycarbonate roofing sheets and accessories. which you can see itemised here. And this even included a 10% discount. So my advice to you would be to shop around, as pricing can vary for this stuff. And the premium aluminium F sections that I've used came to £83 alone, which is ridiculous in hindsight for just 3 long sheets of aluminium. Plastic F sections are available, and obviously whilst not as durable as the aluminium, will reduce the cost of your build. One other thing, I bought this 10-metre length of waterproof LEDs which fit exactly along the diamond structure of the roof.
And secured in position with some galvanised nails I had lying around.
And create a very cool effect when you're sitting under your pergola at night. Now you might be wondering how sturdy this pergola is, because there's always a debate about how thick these posts should be. I'd say 4 inches, which is what these are, is about as narrow as you'd want to go. It does sway a bit if you put your weight behind it, but I'm convinced it will withstand anything that the British weather can throw at it. So that's it for today. For any of you who have bought me a coffee recently or signed up to my Discord chat forum, I simply can't thank you enough, and I'll enclose links to where you can do that in the description below the video, which, don't forget, you can access on your smartphone by clicking on the small arrow, and on your PC by clicking on the Show More button.
The description will of course contain links to all the products and tools featured today.
And finally, if you're new to my channel, it would mean so much to me to have you subscribe. You can do that by clicking on the link here, and don't forget to click the bell notification icon so you get notified of all my future uploads. See you soon.